Let's try to understand harmonic mean. So here, let's say we are given two numbers. Numbers are A and B. Then we have n harmonic means between them. That means there are n numbers which are represented by the sequence h1, h2, h3 all the way up to hn. These numbers are inserted between the two numbers A and B in such a way that the sequence starting with the first term as A and followed by the n number of sequence that we mentioned, and with the last term being B, then this entire sequence is going to form a harmonic progression. Fine. The meaning of this is, let's try to understand it. So let's say we have two numbers A and we have another number B. So what we have done, we are inserting a sequence of numbers. We have H1, H2, H3. So these are the sequence of numbers, and let's say there are n such numbers that are being inserted between A and B. So these are n numbers inserted between A and B such that this entire sequence is going to follow a harmonic progression, or you can say this is a harmonic progression. Fine. Okay. Now, if it is a harmonic progression, then immediately we can say that the reciprocal of each term, that means the reciprocal of the first term is 1 over A, reciprocal of the second term will be 1 over H1. Then we have the third term, its reciprocal will be 1 over H2, fourth term will be 1 over H3, all the way up to the second last term, which is 1 over Hn, and the last term being 1 over B. So this sequence, this new sequence is going to form a arithmetic progression, because that's the definition. If any sequence of numbers are in harmonic progression, then the reciprocal of those terms will be in arithmetic progression. So that means we have the new sequence that is a arithmetic progression. Now clearly here, the first term is going to be, let's call it A1. So the first term is 1 over A. Then we are going to define the common difference with the letter D in uppercase. And we have the nth term. So we call it An. So that will be simply 1 over B. Or nth term is the last term. So let's try to find out the nth term. So the nth term formula is given by A plus n minus 1 times the common difference D. This is the general form of a given arithmetic progression. However, we need to be careful here, because here n is not exactly n. Here n will be, because we have a total of n numbers, h1 to up to n, hn, and we also have to take into consideration the two extra numbers A and B. So that means in fact n is actually n plus 2. So let's place the first term A, so this is A1 actually, with 1 over A, An with 1 over B, and n with n plus 2, and we're going to get a expression for the common difference D. Fine. So in place of An, we have 1 over B. So that is the last term, equals to the first term A1, so that's 1 over A, added to n minus 1, so n is n plus 2 minus 1, times the common difference D. So we don't know the common difference. We'll try to figure it out here. So we have 1 over B minus 1 over A equals to, so n plus 2 minus 1 will be simply n plus 1 times the common difference D. Fine. Or we can rewrite the expression as n plus 1 times D equals to, so combining 1 over B minus 1 over A, we have A minus B divided by AB. And therefore, dividing both sides with n plus 1, we get A minus B divided by AB multiplied to n plus 1. So this is going to be the expression for the common difference. That means if we know the first term, which is A, the last term, that is B, and we also know how many terms are being inserted, then how many harmonic means have been inserted between A and B, then we can find out the common difference D. And once we know the common difference D, we can easily obtain the value of each of the individual terms. Fine. So let's try to understand this with the help of an example. Problem number 1. So here we need to insert 3 harmonic means between these numbers. So let's try to solve the problem without using any formula that we just discussed. So let's say let the 3 terms. So actually we're introducing terms. So let the 3 terms be H1, H2, and H3. So we are inserting them between 1 over 3 and 1 over 19. Such that 1 over 3, this is our first term, followed by the next term, which is H1. Then we have H2, and then we have H3, and the last term being 1 over 19 is a harmonic progression. That is what we need to do. So we are inserting 3 terms between these two numbers, 1 over 3 and 1 over 19, such that the entire sequence of 5 terms is going to form a harmonic progression. Okay, now if it is forming a harmonic progression, then immediately we can say that the reciprocal of each term, that means reciprocal of 1/3 will be 3, Reciprocal of the second term will be 1 over h1. Reciprocal of the second term will be 1 over h2. Then we have 1 over h4 and we have 19 is a arithmetic progression. This is going to be arithmetic progression with first term. So our first term, which is a1, so that's going to be represented by 3. The last term or the nth term, so that's going to be represented by 19. And here the total number of terms is, it's easily 5. 1, 2, 3, 4, 5. So 5. Fine. So we know that the nth term of our arithmetic progression, that's given by the formula, the first term plus n minus 1 times the common difference t. So this is the common difference. Fine. So what we'll do, we will replace the value of an with the last term, so that's 19. So we have 19 equals to the first term, so first term is 3. Added to n. So what is n value? N is actually 5 here. So we have 5 minus 1 times the common difference d, which we don't know yet. So we have 19 minus 3 equals to 4 times d. So 19 minus 3, that's 16. 16 equals to 4d. So solving for d, we get d equals to 16 over 4. So that's simply 4. So now with that, we have the information regarding the common difference. We can find out the terms. Fine. So let's do that. So here, we'll consider the arithmetic progression only. So we have our first term equals to 3. So what's the second term? So that's simply a2. So a2 will be simply, we'll take the first term 3 and add the common difference to it. So that's going to be 7. Then we need our third term. So that's going to be, take the previous term a2 and add the common difference to it. So 4 plus 7, that's going to be 11. Then we have the fourth term. Fourth term will be, take the third term and add the common difference 4 to it. So 11 plus 4 will be 15. And then we'll have the fifth term. So fifth term is already provided, but let's also verify. So what we'll do, we'll take the fourth term and add the number 4 to it. So what's 15 plus 4? That's 19. And we already are provided with this value 19. So that means the terms are 7, 11 and 15 that has been introduced between 3 and 19. But be careful here, these numbers are forming an arithmetic progression. So we have 3, then we have 7, 11, 15 and 19 is a arithmetic progression. This is not an harmonic progression. What we have to do is find the harmonic progression. So what we'll do, we'll take the reciprocal. So we have 1/3, 1 7, 1 11, 1 15 and 1 19. This is a harmonic progression, and when we can say that the three numbers that has been inserted between 1/3 and 119 to form a harmonic progression are 1 over 7, 1 over 11 and 1 over 15. So these are the three numbers. Fine. So let's now talk about a special case where we will discuss the harmonic mean of two given numbers. So let's say A will consider H and B. So let these three numbers form a harmonic progression. If they're forming a harmonic progression, then immediately we can say that the reciprocal of each term, so 1 over A, 1 over H, 1 over B, is going to be a arithmetic progression. Now, if it is an arithmetic progression, then we can say that 2 times the middle term must be equals to the sum of the first and the sum of the last term. So 2 over H will be equals to 1 over A plus 1 over B. So let's further simplify this. So 2 over H will be A plus B divided by AB. Now, if we solve for H, so H will be equals to simply 2 times AB divided by A plus B. So that means for two numbers A and B, the H becomes the harmonic mean of A and B, and it is defined by the formula 2AB over A plus B. Fine. So let's try to understand with the help of an example. Problem number 2. We need to find out the harmonic mean between 1 over 3 and 1 over 7. So we'll try to do both ways. We'll first try to apply the formula and then we'll try to do the usual method. Okay, so let's do one thing. So here we have A equals to 1 over 3 and B equals to 1 over 7. So if H is the harmonic mean between A and B, then H is given by the formula 2AB divided by A plus B. So this will be equals to, we have 2 times 1/3 times 1/7 divided by 1 over 3 plus 1 over 7. So in the numerator, we have 2 times 1/3 multiplied to 1/7, so that will become 2 over 21. And 1/3 added to 1/7, that's simply 10 over 21. So that leaves us with a value 2 over 10 or simply 1 over 5. So that means the harmonic mean between A and B is going to be 1/5. Okay, the other way will be the way how we derive the formula. So let's say, so let H be the harmonic mean between the two numbers 1 over 3 and 1 over 7 such that 1 over 3 comma h, comma 1 over 7 forms a harmonic harmonic progression. Now that it forms a harmonic progression, we can immediately say that the reciprocal of each term, so 3 comma 1 over h comma 1 7 forms a arithmetic progression. If it is forming an arithmetic progression, then 2 times the middle term, so 2 over h, must be equals to the sum of the extreme terms. That means 3 added to 7. So 2 over h equals to 10. So h is simply equals to 2 over 10 or 1 over 5. So either way, we get the same result. So let's try to understand harmonic mean with the help of few more problems. So problem number 3, it's given here that h is the harmonic mean of a and b. Then using this information, we need to show that h over a added to h over b equals to 2. Let us begin. So since h is the harmonic mean between a and b, so that means ahb is a harmonic progression. And we have already defined a formula for h. So h is given by 2 times ab divided by a plus b. Let's divide both sides with 2. So we have h over 2, that's equals to ab over a plus b. Now what we'll do, we'll take the reciprocal on both sides to get 2 over h equals to a plus b divided by ab. Now we can rewrite the expression on the right hand side as a over ab plus b over ab, such that this gives us 2 over h equals to, so a over ab is simply 1 over b, and then b over ab will be 1 over a. Or we can rewrite it as 1 over a plus 1 over b equals to 2 over h. So let's multiply throughout with h. So we have h over a for the first term, h over b for the second term, and 2 over h multiplied to h is simply 2. We have successfully showed that h over a plus h over b equals to 2. Let's go to the next problem. Problem number 4. So it's given here that h is the harmonic mean of a and b. Then we need to show that the following equation is true. So let us begin. Now since h is the harmonic mean of a and b, that does immediately implies that h must be of the value 2ab divided by a plus b. So what we'll do, we'll start a proof from the from the right hand side. So here we have h minus a. So let's try to find out those values first. We have h minus a. So that's simply equals to 2ab divided by a plus b minus a. So this will be equals to, so our common denominator will be a plus b. Then in the numerator we have 2ab minus, so a times a plus b will be a squared minus ab. So that gives us the value ab minus a squared divided by a plus b. So in the numerator, if we take a as the common factor, so we have a times b minus a whole divided by b plus a. So that's the value of h minus a. Similarly, let's also find out the value of h minus b. So that will be equals to 2ab divided by a plus b minus b. This will be equals to, so here we'll have ab minus b squared divided by a plus b, or simply we have b common and we have a minus b multiplied to it divided by a plus b. So that's the value of h minus a and h minus b. So we'll start our problem from the right hand side. So right hand side we have 1 over h minus a added to 1 over h minus b. Fine. So let's substitute the value here. So 1 over h minus a. So we have the value of h minus a, taking its reciprocal is going to give us b plus a divided by a times b minus a. Then plus we have reciprocal of h minus b. So that's going to be a plus b divided by b times a minus b. Fine. So let's combine them. So let's do one more adjustment. So we have b plus a divided by a times b minus a. So what we'll do, we're going to multiply the numerator and the denominator with -1 such that we get negative of b plus a divided by b times b minus a. This is done so that we can easily combine the denominator. So this will be equals to, so we have a times b multiplied to b times a. So in the numerator, we now have b multiplied to b plus a minus a multiplied to b plus a. Fine. Let's further simplify. So we will get b squared plus ab minus ab minus a squared divided by ab times b minus a. So plus ab and negative ab factors out. We have b squared minus a squared. So that's the difference of 2 squared, which is simply the product of b minus a and b plus a divided by ab multiplied to b minus a. Now we can factor out b minus a from the numerator and the denominator, which leaves us with b plus a divided with ab. So we started out with, from the right hand side, 1 over h minus a plus 1 over h minus b. So we started out with 1 over h minus a added to 1 over h minus b, and we ended up with this particular value, b plus a over ab. Now what's b plus a over ab? That's nothing but b over ab plus a over ab. So b over ab means this is 1 over a, and a over ab means we have 1 over b. So therefore we have finally showed that 1 over h minus a added to 1 over h minus b, so that simply equals to 1 over a plus 1 over b. Hence proved. Let's move on to the next problem. Problem number 5. So here provided the harmonic mean of a and b. So using this information we need to find out the value of n. So let us begin. So here it's given that a raised to the power of n plus 1 plus b raised to the power of n plus 1 divided by, we have a raised to the power of n plus b raised to the power of n. So this is the harmonic mean of a and b. So that would mean that a raised to the power of n plus 1 plus b raised to the power of n plus 1 divided by a raised to the power of n plus b raised to the power of n. This must be equals to, now what's the harmonic mean of a and b? That's defined as 2ab over a plus b. So let's try to simplify this. So what we'll do, we'll cross multiply. So we have a raised to the power of n plus 1 added to b raised to the power of n plus 1, and we will multiply it to a plus b. So this must be equals to 2 times ab multiplied to a raised to the power of n plus b raised to the power of n. So we have a raised to the power of n plus 1 multiplied to a plus b raised to the power of n plus 1 multiplied to a. Then we have b raised to the power of n plus 1 times b, and we have b times a raised to the power of n plus 1. So this will be equals to 2 times ab times a raised to the power of n plus 2ab times b raised to the power of n. Okay, so we can combine a raised to the power of n plus 1 with a raised to the power of n to get a raised to the power of n plus 2. Plus, we have a times b raised to the power of n plus 1. Plus, we'll take this term. So we have a raised to the power of n plus 1 multiplied to b plus b times b raised to the power of n plus 1 gives us b raised to the power of n plus 2. So this will be equals to 2 times, so a times a raised to the power of n is simply a raised to the power of n plus 1 times b plus 2 times a times b raised to the power. We're combining b with b raised to the power of n to get b raised to the power of n plus 1. So now what we'll do, we'll keep the first and the fourth term on the left hand side. So we have a raised to the power of n plus 2 added to b raised to the power of n plus 2. What we'll do, we'll take the second term, a raised to the power of b n plus 1, transpose it to the right hand side and subtract it from the second term. And similarly, we're going to take a raised to the power of n plus 1 times b, transpose it to the right hand side and subtract it from the first term. So that gives us a raised to the power of n plus 1 times b plus a times b raised to the power of n plus 1. Fine. Now let's do one thing. Let's bring a raised to the power of n plus 1 times b to the right hand side. So we have a raised to the power of n plus 2 minus a raised to the power of n plus 1 times b, and then we're going to transpose the second term to the right hand side. So we have a times b raised to the power of n plus 1 minus b times raised to the power of n plus 2. The reason why we're doing this was because from these two terms we're going to take a raised to the power of n plus 1 as the common factor. So this will get multiplied to, so from the first term we're left with a, and from the second term we're left with b. So this will be equals to, now we're going to take b raised to the power of n plus 1 as the common factor. So we have a minus b as the common factor. So this simplifies to a raised to the power of n minus 1 equals to b raised to the power of n minus 1, n plus 1. So here we have factored out a minus b from both sides. Now this can be also expressed as a raised to the power of n plus 1 divided by b raised to the power of n plus 1. This will be equals to 1, or simply a over b raised to the power of n plus 1. So this can be also expressed as a over b whole raised to the power of 0. So since the base is exactly the same, we can equate the power or to get n plus 1 equals to 0 or n value equals to a negative 1. So this is going to be the value of n.